Remember, perpendicular means that it's not parallel, okay? It's exactly going to create a 90-degree angle with the other line, okay? Now, in terms of slope, what that means is it's going to have the slope that's the opposite reciprocal, okay? So the first thing that we needed to do was find the slope of this line. Who was able to find the slope of this line, and how do you know it? Zoe?
Well, the slope of that line is -2/1.
Bingo, it's -2/1 because we're going down 2 and then to the right 1. Do you guys see that? So we put -2 over +1. Now, for opposite reciprocal, which would make it perpendicular, what do we need to do? For opposite reciprocal. Sabrina?
You would flip it and then you would change the sign, like the -2, it would then be normal 2.
Bingo. So we flip it. So now it's going to be 1 over -2. And just like Sabrina said, you have to get rid of that negative. So erase the negative. So we're looking for a line that has a slope of 1/2. The only answer is C. Okay? No other work needed to be done. Cool beans? All right, any questions on the warm-up? Yeah, David?
Why did you flip it?
Why did I flip it? Because it says perpendicular. Now, if this question asked us to find the line that's parallel, what would be the answer? If it asked us to find the line that's parallel, which of the multiple choice questions would be the answer? Or which of the multiple choice? Carl? A, excellent, okay? Because A has the same slope. B and D are variants of that same slope, which was -2, but neither of those are the right answer. They're neither parallel nor perpendicular. Cool beans? All right. Not on Friday. On Thursday, we talked about linear inequalities, right? With two variables, so X and Y. Today, we're talking about a system of linear inequalities, which just means how many are we going to have? Dos, okay? 2 or more. Because remember, a system means that you have 2 or more equations. Now we're talking about inequalities. So we're going to have 2 or more inequalities. All right. So now when we're checking whether something is a solution or not to a system of linear inequalities, guess what? It has to satisfy both of them. So in that definition, I need you to highlight the word each, okay? Each of the inequalities in a system must be satisfied. If one is not satisfied, guess what? It's not a solution, okay? If they're both satisfied, it's a solution. If neither of them are satisfied, it's not a solution, okay? So you need the whole thing or nothing at all, okay? Now, just a little refresher before we dive into the examples. Is 4 less than or equal to 4? Yes. Is 4 less than 4? No, okay? So just remember, if there's that equal sign, the left side can be equal to the right side, and if there's not that... If there's no equal sign, the left side cannot be equal to the right side.
Everyone coughing today.
Checking our solutions. Okay, so in example 1, we're going to tell whether each ordered pair is a solution of the system of linear inequalities. Guess what, guys? All you got to do is plug it in, okay? So my x is going to be 3. My y is going to be 5. We plug them in. So we've got to do the first one. We've got to do the second one. So we're going to plug it into the first one. We've got 5 is less than 2 times 3. And 5 is less than, what's 2 times 3, peeps? 6. Is 5 less than 6? Boom, we've got half of it done, okay? Then we do the second one. We have to plug it in, so we're going to get 5 is greater than or equal to 3 plus 1. Is 5 bigger than or equal to 4? Yeah. If they both work, we circle this, and we say it is a solution. That's it. Now, this is the easy part of the lesson, okay? So let's kind of zip through this. Guys, notice how I wrote it. It is a solution. Why do you think I wrote it? It is a solution. Because there's more than one solution, okay? Remember, for these inequality questions, okay, you're not just going to get an x and y. It is a solution because there's more than one solution. Cool beans? In B, we plug it in. Make sure if one of them doesn't work, you don't need to do all of it, okay? Just once one doesn't work, you're going to stop it. Hold on. Y is less than 2x. So what we're going to do is we're going to say, okay, plug in y is 0, plug in x is -2. So we plug those in, we're going to get 0 is less than 2 times -2. This is going to give me 0 is less than -4. Agreed?
Yeah.
Is 0 smaller than -4? No. So do we need to keep going? No, we circle it and we say it is not a solution. Not a solution. Okay? Why are we saying it's not a solution?
Because it's incorrect.
Correct. Is there a solution to this inequality?
Yeah.
Yes, but the one that they gave us to test out is not it. Okay? There could be more than one solution, but this one for sure is not one of those
So
solutions.
this entire lesson is basically just plugging it in.
Pretty much. Okay? Now we also have to graph it. Okay? That's the more difficult part. Okay? Diana, what's up? Where?
We didn't do the bottom one.
Oh, I know, like, for B, y is greater than or equal to x plus 1.
We didn't do it.
Who's y? Oh, you didn't?
Oh, no, I didn't do the bottom one. Once one of them doesn't work, Diana, you can stop.
Oh.
Okay? Zoe, what's up? Do you have to circle it? No. As long as you write not a solution, I'm cool. Okay? All right, let's do C and D. Come on. Come on. All right. Plug in X, plug in Y. The first one's going to give you 5 is less than 5. True or false? No dice there. That's false. So this is also not a solution. Cool beans? Okay. You don't even need to touch the second one if the first one doesn't work. Got it? D. Y is greater than or equal to 3x plus 1. Let's go ahead and plug in. We're going to get 4 is bigger than or equal to 3 times 1 plus 1.
Yes.
This is going to be 4 is greater than or equal to 4. And like Ali said, that is completely true. And the second one, 4 is greater than 1 minus 1. This is going to be 4 is bigger than 0, which we should all know is true. So if they both work, we can say that this is a solution.
Can I ask you how your weekend was?
And guys, unfortunately, that was the easy part. Oops. All right, let's jump to graphing them. Okay, now, when we're talking about graphing, okay, we did graphing on Thursday last week, okay? Now, what we did, though, was we graphed one of these at a time, okay? Now we're going to be graphing 2 inequalities on the same axis, on the same coordinate plane, and we're going to find out where they overlap, okay? So, where they overlap, this is the solution. Because what this is saying is, below the blue line, right, is the blue shaded region. Do you guys agree?
Yeah.
And then above the red line is the red shaded region. Do you guys agree?
Yeah.
So any point up here in the top where it's only red only works for which of the 2 inequalities?
That one.
The red one. And any point you see down in this very blue region, any point like down here only satisfies which inequality?
Blue.
The blue one. Now, points in this purplish region, guess what?
Both.
They satisfy both, okay? So this is our solution section, okay? Now, points over here, do you see this empty space right up at the top? They don't work for either one, okay? So if there's a part in your graph that isn't shaded at all, it doesn't work for any of your inequalities, okay? Cool beans? All right, let's check it out. So we're going to do some of these. Let's check out the first one, okay? We're going to graph the system of linear equations. Now, Thursday was a long time ago because it's already Tuesday. So let's go ahead and refresh our memory on what we do for linear inequalities, okay? Let's underline this first one. I'm going to underline it in blue. Make sure you use 2 different colors for both the inequalities. And let's write step number 1. Who remembers what step number 1 was? Sabrina?
To replace the thingy with the equal equation?
Replace the thingy with the equal sign. Yes, it is y equals 3. Now, we call that thingy, it's an inequality symbol. Okay, so we say y equals 3. What kind of line is y equals 3, people? Camilla? Horizontal. Very good, okay? So we're going to put a horizontal line at y equals 3. Bear with me, guys. I'm not a notability, so my lines are not very straight. That's good enough, okay? Now, the second thing that we do is what?
Plot on the diagram.
Zoe? Excellent, okay? We need to pick a test point. And I told you guys, you should always try to use what point? 0, 0. Okay, so put a dot at 0, 0. Now, ask yourself, is 0, 0 on the line that I just drew? No, so we're okay to use it, okay? If it was on the line, we would need to pick any other point. Got it? Okay. So now step number 2, I'm sorry, that was step number 2. Step number 3 is, okay, we're testing 0, 0. So we need to plug that back into our original inequality, okay? Now guys, look up here. This is super important, okay? I know a lot of us are going to make this mistake and plug it in here. And we're going to get 0 equals 3, okay? Don't do that. Plug it into the original inequality. Do you guys see that? Okay? Because you need an inequality to make sure that you are testing it, okay? So we're going to plug it into the original. Y is going to be 0. So 0 is less than or equal to 3. Is that a true or a false statement? True, okay? So if it's true, we want 0, 0 as part of our solution. Do you guys agree? Now, is 0, 0 above or below our line? Below. So if it works, then we need to shade the region below. Okay? So we're going to take out our highlighter in blue and shade the region below our line. Cool beans?
Yeah.
You know we're tired when we don't answer you.
I know. You guys are exhausted. I am too, though. Can't blame you.
It's been a very, very long weekend. Right,
Okay.
Mama?
So we are exactly halfway done, okay? We've graphed one of the lines, and we've also shaded in our region, okay? The second equation is y is greater than x plus 2.
That's crazy.
So let's do the same exact steps. Step number 1, rewrite it as y equals x plus 2. Does anyone remember what we call this line that we're graphing? The line part? Starts with a B. The boundary line. Very good, okay? So we're graphing the boundary line so we can figure out which region we need to shade, okay? So y equals x plus 2. How do we graph that? Go ahead, Zoe.
You put 2 on the right axis,
Yep.
and then you go up 1 to the right one.
Excellent. Up 1 to the right one, up 1 to the right one, up 1 to the right one. Okay. Now, our first line was a solid line. Should this one be solid or dotted? It is going to be dotted. Why? Because of this symbol. Do you guys see this symbol in the beginning? Layla, why does it need to be dotted?
Because it's not equal to.
Excellent. It's not equal to. Do you see how the first one had an equal to symbol down below? It has that line underneath. Okay? That means that our boundary line is included in our solution. When it doesn't have that, your boundary line cannot be part of your solution. It has to be a dotted line. Got it? Okay, so we're going to draw a dotted line as best we can through all these points. I know I can't. I'm not in Notability, but thank you. Okay? So we're drawing a dotted line like that. Now, second part, we don't know which side to shade, do we? So, what are we going to do? Sabrina?
We're gonna plug in 0.
0, 0, baby. Okay? We put 0, 0 here. Can we use 0, 0 here? Can we use 0, 0 here? Yes. Okay? We can. Does our red line go through this point? No. And if it doesn't, then it's not on your boundary line. You're golden. Okay? You're just trying to pick any point that's not on your boundary line. Okay? I always want to use 0, 0 because it makes it the easiest for plugging in. Because you're just going to get a bunch of zeros, okay? Now, step number 3, plug it in. So 0 for y is greater than 0 plus 2, okay? 0 is going to stay 0. What's 0 plus 2, guys? 2. Is 0 bigger than 2? No. So this one didn't work. Now, take a look. Is 0 below or above the red line? Below. Now, it should not be a part of our solution. So what should we shade? Above it, okay? Now, if 0, 0 worked, do you see how for step number 3 it didn't work? We should not be shading this side where 0, 0 is on, okay? We're going to shade the other side, okay? So if 0, 0 did work, then we would shade this side back down below. But since it doesn't work, we're going to shade above it, okay? So we're going to take the red line and shade above it. Now, do you guys notice where they overlap? in that little, it almost looks like a 7, right?
Kind of looks like a triangle.
Or
Almost
it
looks like a triangle.
Or it just looks like a dark purple.
Go ahead and write in there, this is your solution set.
In my solution, what?
Solution set, okay? That means any point in that purple-ish region will work for both inequalities. That is your solution set. On the test, I'm looking for a darkly shaded region that overlaps with each other, okay? So on your test, you're gonna lightly shade each of these regions, right? And wherever they intersect, you're gonna draw a line to it. Right in there, this is my solution. Or just make sure that it is significantly darker than the other two shaded regions. Got it? Wherever they overlap. Okay, let's try another one. B, you guys are going to do on your own, okay? A lot of people have been making the mistake. Don't put B in right now. You guys are going to do that one on your own. We're going to jump down to C. So everyone go to C, okay? In C, let's go ahead and start with the first one. Negative 2x plus y is less than 4. Step number 1, write it with an equal sign. Negative 2x plus y equals 4. Now, before I graph this, what should I do? Emma?
Make it into slope intercept form.
Excellent. How can I make this into slope-intercept form?
Add 2x to both sides.
Perfect. Add 2x to both sides. So we're going to get y equals what?
Y equals 2x plus 4.
Excellent. 2x plus 4. So in order to graph that, we're going to start at our y-intercept, which is 4. And we're going to go up 2 to the right 1, because our slope is 2 over 1. Up 2 to the right 1. Or we can go down 2 to the left 1. Down 2 to the left 1. Okay? And we should get a line that is dotted. That looks like this. Why is it dotted? Zoe?
Because there's no line under the sign.
Excellent. Mm-hmm. Step number 2. Step number 2, we are going to check whether 0, 0 can be used or cannot be used, okay? So, where's 0, 0? Right in the middle, right? Does our line go through that point? No, okay? So we can use it. So 0, 0 can be used. That's going to be our checkpoint, okay? So, step number 3. Plug it in and test it, okay? So plug in 0 for x, plug in 0 for y to your first inequality. We're going to get negative 2 times 0 plus 0 should be less than 4.
Part of the interruption, Daniela, correct?
What's negative 2 times 0? And what's 0 plus 0? 0 is less than 4. Is this true or false? True. So we put a check mark. And since it works, we need to shade the side that includes 0, 0. So we're going to shade the right-hand side. Do you guys see that?
Yes.
If it didn't work, which side would we shade? The other side, okay? The left-hand side. Because right now, every single point in the shaded region is part of our solution, okay? It works for the red inequality. All right, and then let's do the second one, the blue one. 2x plus y is less than 4. So we're going to say step number 1, rewrite it with an equal sign. 2x plus y equals 4. Subtract 2x from both sides. You're going to get y equals negative 2x plus 4. And then we graph it, okay? We're going to start at 4 again. We're going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And then we're also going to draw a dotted line because it was greater than, okay? Not equal to. And we're going to draw a dotted line down like this. Beautiful. Okay? We've got our line. Now we just need to figure out, okay, which side do we shade? Step number 2, test our point 0, 0. We can use it here because it's not on our line. Do you guys see that? See how our line does not go through the point 0, 0? That means we can use it. Step number 3, plug it in. Okay? So we're going to plug in 0 for x, 0 for y. We're going to get 2 times 0 plus 0 is greater than 4. So 0 is bigger than 4. Is that true? Is 0 a larger number than 4? No. So it doesn't work, okay? That means that we're not going to shade the side with 0, 0 on it. We're going to shade the other side, okay? So, for the blue line, is our point 0, 0 on the left or the right of the blue line? It's on the left side, right? So shade the other side. It just disconnected? Perfect. Just what I
think
want.
that's the time where we start watching the movie.
Colors.
Look how pretty it looks. Oh my god.
Looks nice, right? The first one should have been fairly easy because it's already in slope-intercept form, right? So my equation is for the first one, y equals 2x minus 3. Agreed? So I'm going to start at -3, go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. Okay? And then it should be a dotted line because we're using a greater than symbol. So we're going to have a dotted line here that looks like this.
Nice dotted line.
I know, I'm sorry. Pretty horrible, okay? All right, now, step number 2 is figure out, okay, which point do I want to check? Can I check 0, 0? Yes, because it doesn't go through our line. So 0, 0 is a good point to check, okay? And then step number 3 is actually plug it in and see whether it works or whether it doesn't, okay? So step number 3, we plug in 0, 0. We're going to get 0 needs to be bigger than 2 times 0 minus 3. Is 0 bigger than -3? Yes, so that one works. So we need to shade the side that 0, 0 is on, okay? So the side that we're going to shade is the side above or technically to the left of your red line. So you should have shaded this section of your graph. Cool beans? Okay. So we got this section. Now the second part is figuring out, okay, what do we do with the second inequality, okay? So we're going to follow the same 3 steps and we're going to see where they overlap. So second part, let's do that one. I'm going to do it in blue, okay? Step number 1, rewrite it. Y equals 1 over 2x plus 1, okay? We're going to start at 1. We're going to go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. It's going to be a solid line because it says y is greater than or equal to 1/2. So it's going to look like this. Okay. You guys with me so far? Okay. Now, we also have to test 0, 0. And it is a good point to test because it's not on our line. So we're good there. Step number 3 is actually plug it in and test it. So is 0 bigger than or equal to 1 over 2x, which is now 0, plus 1? Well, this is going to be 0 is bigger than or equal to 1. Is that true or false, people? False. So we need to shade the section of our graph that does not have this point because it was not a solution. Do you guys see that? So is the point below or above our line? Below. So we need to shade above because it doesn't work, okay? So we're going to take out our blue highlighter and shade above this line. So now our double shaded region is that top left portion. Do you guys see that? So this region up here is our solution set. I thought someone was they
Take
can.
him back.
You can go, yeah.
Do we need to take a count?
Yes, please. So guys, if I picked a point, if I picked this point, negative 10, comma 2, which inequality would it work for? Zoe? Both of them. If I picked a point down here, which inequality would it work for? The red one, or the first one, right? If I picked a point over here, which inequality would it work for? The blue one, okay? Y greater than or equal to 1/2 x plus 1. And if I picked a point over here, which one would it work for? Neither. Do we see that? Okay. Moving on. Really quickly, how do you know which side of each boundary line to shade? Who can answer that question for me? David?
Oh, that's the point 0, 0 works.
Yeah. So we have a test point. You test a point. If it works, shade that side. And if it doesn't work, David,
Don't shade it.
shade the other side, right? And if it doesn't work, shade the other side. Cool beans? Previous examples, okay? What was our solution? What do we call our solution set? Camilla? Very good. The part where both the shaded regions were together. Now, inequalities, okay? Now, that one is going to have no solution, okay? So I need you guys to pay close attention to what our graph looks like and why there is absolutely no solution, okay? Now, what do you think would happen if there's no solution? What's that, Zoe? There's no shading, right? Well, we know that there's going to be shading because it's an inequality, but here's the trick, Zoe. They're never going to overlap, okay? So it's going to be two completely different shaded regions that never overlap. Therefore, there's no solution, okay? Let's check it out. So the first one, we follow the same steps. 2x plus y is less than -1. Step number 1, 2x plus y equals -1 for our boundary line. We are going to change this to slope-intercept form by subtracting 2x from both sides. So we've got y equals -2x minus 1. And that means we're going to start at -1, move up or down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. This is going to be a dotted line because it's less than. Yeah. Yes. Okay. This is going to be a dotted line. And then second thing we need to do is test. We want to use 0, 0. Let's see if we can. Is 0, 0 a point on our line? No, so we're okay to use it. Step number 3, plug it in. Okay. So we plug in 0, 0. We get 2 times 0 plus 0 is less than -1. Is 0 smaller than -1? It is not, okay? It is bigger than -1. Therefore, we are going to shade on the other side. So since this didn't work, we're not going to shade the side with 0, 0. We're going to shade the side without 0, 0, which would be the left side, okay? Okay. Next one, we've got 2x plus y is greater than 3. Step number 1, you rewrite it. 2x plus y equals 3. You subtract 2x from both sides, minus 2x minus 2x. Y equals -2x plus 3. We start at +3. We go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Okay? You're going to get another dotted line that looks like this. What do you notice about those two boundary lines? They're parallel. They do have the same slope. So test number 2, you have to test the point 0, 0. It's good to use in this case because it's not on our line. If it was on our line, you could use any other point. Step number 3, plug it in. So we've got 2 times 0 plus 0 should be bigger than 3. I'm plugging into the original inequality, the first one that I was given. Is 2 times 0 is 0, add 0 to that, you get 0. Is that bigger than 3, guys? No, so this one also doesn't work. So the 0, 0 is to the left of our blue line. Do you guys agree? So do we shade that side or do we shade the other side? The other side, okay, because it didn't work. So you shade this side. Are these two regions ever going to overlap? No, okay? So therefore, this is an example of no solution, okay? So we would write no solution. Because the two shaded regions never overlap. And you can just write a little note, there's no overlap. Okay, I want you guys to work on example B, and then we're donezo.